how large language models work their magic. So these large language models have tons and tons of parameters, which are like the knobs and dials that control its processing. The model tunes these parameters based on patterns it sees in massive amounts of training text data. Now, to generate text, these models break down everything into smaller chunks called tokens, kinda like Lego blocks. For a word like football, it may have tokens for foot, ball. For a video caption, tokens may be individual words, names, punctuation, whatever. When the model gets input tokens, it converts them into dense vectors called embeddings. This encodes what each token means based on the training data. As the input passes through the model layers, the tokens get updated embeddings based on context. Then, the model uses its parameters and embeddings to predict the most likely next token. Rinse and repeat. It keeps generating tokens one by one, using previous tokens as context. And voila! We have generated text like captions, articles, scripts. Of course, there's a lot of complex math under the hood, but hopefully this gives you an idea of how LLM models leverage parameters and tokens to understand and generate language. Imagine a time when language models were just starting to gain steam. It's the year 2018. Google's BERT makes its debut, boasting 110 million parameters and a token length of 512. This model was built to handle sentence-level tasks with finesse. That same year, OpenAI introduces the GPT model, bringing transformers into the realm of language generation, albeit with a token context capacity of just 1,000. So, 2018 marked the beginning of an era, the era of large language models. Fast forward to 2019, the year when the parameter and token length started to increase substantially. Google stepped up the game with its T5 model, boasting a massive 11 billion parameters and a token length of 1,024. This model opened new horizons, as it was trained on diverse datasets. That same year, NVIDIA introduced the Megatron-LM model, a powerful tool with 8.3 billion parameters capable of processing 2,048 tokens, thanks to the use of model parallelism. As we moved into 2020, OpenAI's GPT-3 made waves in the AI world. This model, with a staggering 175 billion parameters and a token length of 2,048, enabled strong few-shot performance on paragraph-level generation. The year 2020 truly represented a leap in the development of large language models. As we entered 2021, the large language models became even more powerful. Google launched its Switch Transformer, a behemoth with 1.6 trillion parameters and a token length of 4,096. This model pushed the limits of what was previously thought possible. Alongside this, the Jurassic 1 conversational model made its entrance, boasting 178 billion parameters and a token length of 3,072. As we moved into 2022, Google introduced another heavyweight, the Palm, with 540 billion parameters and an astonishing token length of 8,192. Not to be outdone, Anthropic's Claude model came onto the scene, carrying 12 billion parameters and a token length of 4,096. While 2022 continues to push the boundaries, the future holds even more promise. As token lengths and parameter counts continue to grow, we edge closer to a world where AI can assist in creating complex content like books or films. The future of large language models is indeed exciting. Looking ahead, the potential of large language models is immense. Imagine the possibilities with trillions of parameters and token lengths in the tens of thousands. We could see computer-assisted creation of entire novels, films, and more. However, as we push these boundaries, we must remember the importance of balance. Larger parameter sizes and token lengths drive more sophisticated language modeling, but also demand significant computational resources. It's a journey of discovery and innovation, and we're just getting started.